All right, now a trapezoid is kind of a strange object. We have two sides parallel, and that's it. And it turns out that the area of the trapezoid is given by this strange type formula. So, strange object, strange formula, seems consistent. Can we make sense out of the formula? Well, first of all, let's take a look at what the formula is saying. So here I've got a trapezoid, and I'm told that the length of the bottom base is B2, the length of the top base, or the roof, is B1, and the perpendicular height between the roof and the floor is given by H. Then the area is alleged to be B1 plus B2, quantity times H, all divided by 2. The big mystery is, where's the 2 coming from? Well, we can see that, and let's see how. We'll take another copy, exact copy of this trapezoid, but turn it around, so rotate it around, and notice it fits in perfectly, like a jigsaw puzzle. And now, if you think about it, you can actually prove that these two sides are parallel. So I actually have a parallelogram. All right, now if I have a parallelogram, I know how to find the area of a parallelogram, right? It's base multiplied by perpendicular height. So that would be B1 plus B2 multiplied by H. So the area of this big thing is actually B1 plus B2 all multiplied by H. So what about the area for this half of it? Well, if I want to get half of it, I just divide by 2. And so, in fact, really, this expression there represents the area for the two trapezoids put together because they form a parallelogram. And then, since I only wanted the one, I divide by 2. There's the formula. It makes complete sense. Excellent. Now, let's apply it to some interesting questions. So the first fascinating question I want us to consider is the following. Let's find the area of a trapezoid that has a B1 of 8, a B2 of 10, and a height of 5. Well, that's really easy since we know the formula. It's going to be a walk in the park, as they say, because the area is going to be, and you can think about this if you want as the average length of the bases. You take the first base, the second base, you add them up, divide by 2, that gives you the average. So we have to average 8 and 10, so that's going to be 8 plus 10 divided by 2, and then we multiply by H, which is 5. Well, so 8 plus 10 is 9 divided by 8 plus 10 is 18 divided by 2 is 9. So we have 9 times 5, which equals 45. Units, these are areas, so it's centimeters squared. See? No problem at all. Let's take a look at another example. In fact, we can take the idea that we use for the trapezoid, and we can actually figure out the area for a triangle. The area for a triangle, which some people might have actually already heard of, is just 1/2 base times height. And that's also clear because it's the exact same idea. If I take another copy of the triangle and rotate it around, I produce another parallelogram. The area of the parallelogram is base times height, but again, I only want half of that because the triangle is only half of the parallelogram, so I take half. Exact same reasoning. Isn't it sort of neat how you can take one idea and you can sort of apply it again and again and again? You can recycle ideas. I love that. So, let's see if we can apply this recycled idea. So, we have a nice little triangle here. The base of the triangle, we don't know. It's B, and I want to find it. All I know is that the perpendicular height is given by x minus 1 feet, and the area we know is x squared minus 1. So what do we do here? Well, we know the formula for area. So we have that area equals 1/2 the base, which I don't know, so I'm going to call that B, multiplied by the height, which I do know, is x minus 1. Notice how I put the x minus 1 in parentheses, because all of that stuff has to be multiplied by the 1/2 B. All right, now we do know what the area is. It equals this algebraic expression, so let's write that out. X squared minus 1, and that's supposed to equal 1/2 B times x minus 1. All right, what to do first? Well, I think the 1/2 desperately needs to be dealt with. So let's multiply both sides of this by 2. So if we hit this with a 2 on both sides, then the 2 divided by 2, that just gives me 1, so they go away, and I'm left with 2 times x squared minus 1 equals b times x minus 1. I want b alone, so I better divide both sides by x minus 1. Okay, and now notice that the right-hand side simplifies just down to b, which is awesome. Now, the left-hand side, it might look like they cancel completely, but notice that actually this is an x squared, and this is just a naked x to the first power. So they're not going to cancel exactly, but the numerator can be factored. And once we factor it, we'll see something really neat. So if we factor, I see 2 times x plus 1 times x minus 1 all over x minus 1, and that equals b. And now you can see an x minus 1 factor in the numerator and the denominator. We can cancel, and so I see that b equals just 2 times the quantity x plus 1. So b equals 2 times x plus 1, or if you distribute 2x plus 2, the units here are feet. And so we see that we can even find the length of a base just knowing the area and the height, even with the x's. We just keep the x's in there. It's a little more abstract, but we can still find it because of this basic relationship. All right, cool. Let's try one last one, just for fun. I want us to find B1, the length of the roof of this trapezoid, in which the area is told to be 22. So that's 22. The height we see is 4, and we see that the floor, the bottom base, is 6. What do we do? Well, to find the area, I can show you the formula, which I'll do in a second, but let's think through it. What do I want to do? I want to take the average of the bases, which means add them up, divide by 2, multiply by the height. Is that really correct? Am I good or am I good? Take the average of the bases and then multiply by h. Good. Right on target. So let's do that. What would we do first? Well, I'd say that the area is 22, and that's going to equal the average of the bases. So I take B1 plus 6 and divide it all by 2 and multiply that by 4. And now I'm going to solve. All right, well, actually, I can do a little bit of simplification here because 2 divides in evenly into 4. Leaves me with a 2 here. And then if I divide both sides by 2 right away, these 2's cancel, and I'm left with 22 divided by 2 is 11, equals B1 plus 6. I subtract 6 from both sides now. And what am I left with? I'm left with the fact that B1 equals 5. My units are inches, and so I've got 5 inches. So just using our minds and thinking through the analysis, just some basic formulas naturally come out, and we can apply them in a variety of different ways.